Hello and welcome to my demo of Kraken. Kraken is an infrastructure as code tool for Kubernetes in which users provision cloud infrastructure using declarative configs. These configs can contain references to state created by other infrastructure resources. This is made possible by the core Kraken APIs that provide a standard mechanism in which state can be imported and exported. APIs that specialize in providing a specific type of cloud infrastructure can implement this standard and integrate with other resources through the core Kraken APIs. The core APIs also include a controller that allows generated infrastructure state to be exported to Kubernetes native objects such as config maps and secrets. Okay, so what are we going to build today? We've got a simple enough kind of infrastructure set up that demonstrates some of the dependencies on how they're reconciled in Kraken. So we've got a config map here. We can imagine that that's being created by some other Kubernetes resource. And that config map is dependent upon by two EC2 instance resources. So they depended on this key, one depends on this key image ID, the other depends on the key image ID and max count provided by config map A. Additionally, EC2 instance B also depends on a generated value from EC2 instance A. In this case, the path instances.0.instance type. So it's a JSON path that it references. We also have two config export resources, and these both depend on generated state from these EC2 instances. So in this case, config export A references a path to the VPC ID and the subnet ID of EC2 instance A, and it creates and manages a config map on the cluster. And config export B depends on the instance ID of this EC2 instance, and it creates and manages a secret. And we can imagine that these config map and secrets could be consumed by some other Kubernetes resource. So I have a base setup here. I've created a locally running Kubernetes cluster. I've installed Cert Manager for providing certificates. I've installed Argo CD, which is a GitOps tool for Kubernetes. We'll be using that later. And I've installed the core Kraken components. So these are installed by referencing a GitHub repo and a tag on that repo, tagged ref. So this installs the custom resource definitions, any other config that's required, and also the controller deployment, which will be tagged at this version as well. So once that's installed, we can install any infrastructure resource. So I've installed the EC2 instance controller components, and to do this, the user first has to create some AWS credentials and a secret on the cluster, and then they can, similarly to above, use a GitHub ref to install a specific version of the controller and all the components that are required. Okay, so once those are installed, we can start creating our config. So I'll start with the config exports. Let's just inspect these before applying them to the cluster. So config export A creates a config map of name config map B in the default namespace. It contains two keys. The first key, my VPC ID, takes a value from a Kraken resource reference. And this Kraken resource is of kind EC2 instance with name EC2 instance-A, and the path to it is the path to the value is instances.0.networkinterfaces.0.vpcid. So that's a JSON path to the value required. And then the second key, similarly, my subnet ID, value from a Kraken resource of kind EC2 instance with name EC2 instance A, and this time looking for the subnet ID from that resource. So config map or config export B creates a secret on the cluster, named secret A, and it has one entry, which is a key called my instance ID, which takes a value from Kraken resource reference of kind EC2 instance, name EC2 instance B, and the path is to the instance ID of that EC2 instance. Okay, so if I apply both of these to the cluster, we can inspect them or get them and see the status. And as expected, the status says ready false because it's missing a dependency, and the state declaration for kind EC2 instance of name EC2 instance A does not exist because we haven't created that EC2 instance yet. Similarly, config export B will have a message to say that that instance doesn't exist as well. So we need to create these instances. So let's inspect these. So EC2 instance A has some kind of concrete values. We don't need to worry about those, but it also has a reference to a value. The image ID is reference to a value from a config map of name config map A, and the key we're looking for is image ID. EC2 instance B also has some config map references. It also takes this image ID from config map A, but it also takes the max count value from that config map too. Additionally, EC2 instance B takes a value from a Kraken resource reference. So EC2 instance A, which is this instance here, it takes the generated value instance type from that. Okay, so if we apply both of these to the cluster and get them, we can see that config map A does not exist. That's because we have not created that yet. So it's giving a kind of useful message to say that we need to create that config map before this resource can be reconciled. Similarly with EC2 instance B, it shows that config map A does not exist. So let's just take a look at the current progress. We've created the 2 config exports and the 2 EC2 instances. But none of these can be reconciled because they depend either directly or indirectly on this config map, which we have not created yet. So once this config map is created, all of these will be reconcilable. So what I'm going to do is create the config map now, and I'm going to set up watches for the 4 resources, the config exports and the EC2 instances, and these watches are watching the status of each of these resources. So as the statuses become reconciled, we should see these update, and we should see that the state has been reconciled. So after some time, we see a state transition. EC2 instance A has become reconciled because the config map was created and it was able to create the instances. When that EC2 instance was reconciled, it exported its state, which allowed config export A to be fully reconciled. And you can see a message here that config has been successfully exported for that. So currently, EC2 instance B is reconciling. Actually, it's just finished because it had just received the values required to reconcile. So if we go down to the last condition, you can see that that has been reconciled because all dependencies were created and or were available, I should say. And then config export B was created finally when EC2 instance B was reconciled. Okay, so that demonstrates some of the dependencies in action and how that affects reconciliation. And we can also update any of these resources, and they will impact the dependent resources as required. So in this case, I have updated a config map A to contain the data max count of instances to 2. It was 1. So we should see that that will update the EC2 instances for EC2 instance B. So if I go to my browser and show the EC2 console here, we should see instances have now progressed to 3 running instances. It was 2 before, but since this config map was updated, it's now 3. Okay, so finally we can delete all of these resources at once, and we're just deleting the entire directory. So we'll delete these. You should also see in the AWS console that we now have 0 running instances. Okay, so finally another way of managing this is with GitOps with Argo CD. So in GitOps, we use a GitHub or remote repository as the source of truth for our configs. So I'm just logging into Argo CD using the CLI, and I'm going to create an application on Argo CD. Argo CD is basically an agent that runs on the cluster that watches a GitHub repo and tries to make sure that repo's state is in sync with what's on the cluster. So this app is pointing to the GitHub repo for this demo, the path to a directory in that repo, demo config. The server is the server that the agent is running on, and it's going to create configs in the default namespace. So we can see that the application was created. And if I go to the Argo CD GUI, I can log in as admin, and we can see that my infra has been created, and it shows that it's out of sync. So if I hit sync here, so manually sync it with the repository, we could set it so that it would automatically synchronize, but I'm not doing that here. So you can see that it's after creating all of our resources for our demo in this group, and each of these resources has created a dependency request for the values that it requires. As values become available, they'll be populated to the status of this dependency request so that the state can be reconciled. So we should see this progressing shortly. So EC2 instance A is currently creating instances, and when that's finished, it will create a state declaration of the generated state, which will be used by other resources. There we can see EC2 instance A has created its state declaration, and that allowed config export A to create a config map on the cluster. We can quickly just inspect this state declaration to see what kind of data it's exporting. So here's our instances and various data about these instances, and it also exports its spec. Don't need to worry about that now. So EC2 instance B now has all the required state to reconcile. So it's just finished reconciliation now. It's created its state declaration, which can be used by config export B to create a secret on the cluster. So that's how this could be managed in a GitOps environment. And of course, we can delete this here as well. Okay, that's it for this demonstration. Thank you for watching.